So now in this video we're going to talk about convex mirrors. So if I take my circle tool and once again we're going to make a little circle with my circle tool, and we'll put that right there, and so now the key thing is this is the front and this is the back. So the front side of the mirror is on the outside of the curve, and the inside of the mirror, the inside of the curve, is the back side of the mirror. And so once again we have our optical axis, and we go halfway in 1, 2, 3, 4, 5 and a quarter. And so we have, this is our center, otherwise known as 2F, otherwise known as the radius, and this is our focus right here. And call this okay. Now we have our person out here with a little light bulb on their head, and we'll make them like this size. And we're going to do sort of more or less the same things. The rules haven't really changed at all. We're going to go in parallel, and now we're going to go out, mind you, along a line through the focus. So we don't actually, the light isn't actually going to travel through the focus. It can't travel through the focus because there's a mirror in the way. But it bounces out like this. And then we say an object that goes in parallel, that goes in at a certain angle is going to bounce out at that same angle. But we're going to back that up. Some of you guys are going to guess that where we're going to end up with is a virtual image. And then a ray of light through the focus, so it's going through the focus, but it can't get there because there's a mirror in the way. So it's going to leave parallel. And again, we're going to back that up. And so these three lines, they actually don't meet anywhere, but they virtually meet back here. So here is our virtual image. And so, and then again, if we sort of did this out, you know, I didn't actually really sort of do it out. I'm sort of halfway between doing it the complex way and halfway between doing it the simplified way. In the simplified way, you could just draw the mirror as a straight line. You don't have to draw it as a curve like I did. You can just do it exactly like, you can just do it like this, but instead of having the focus over here, you now have the focus back there. So, but still, again, coming back to our original idea behind mirrors is that the angle of incidence, there's a normal right in here. There's a normal, and we still have theta I is equal to theta R. So the angle of incidence equals angle of reflection. That's still happening. Okay, so now we have 1 over I is equal to 1 over F minus 1 over O. And now the latest wrinkle is I'm saying my focus was 5 1/4. Well, it should be 5 3/4 actually. I think I just drew that wrong. So the focus should be 5 3/4, but it has an interesting feature, which is it's now negative. Because the focus is now behind the mirror, the focus is going to be negative. So F is negative. And then my object is, let's see, 1, 2, 3, 4, 5, 6, 6.5. And so if I get 1 divided by minus 5.75 minus 1 divided by 6.5, and then I have to take the inverse of that, and I get -3. So I is equal to -3 centimeters. And I check that on my diagram, and here's 1, 2, 3, and I'm off a little bit because I actually drew it as an actual curve. Your diagrams are going to work much better if you just draw this as a straight line. So I haven't really given you a really good example of exactly how I want you to do convex mirrors, but you should be able to figure it out from other materials that I've produced. And then the last thing I want to say is I want to have a rule for convex mirrors. Okay, image is always virtual and magnification is always less than 1. Okay, so there's mirrors, and I'm pretty sure that I'm almost done. I'm just going to talk about additive and subtractive color for just a second in the next video.